All right, welcome. Today we're going to crack open this builder's kit for machine learning. We're going to unpack it, piece by piece so we can really get a handle on its core concepts, how it all works, and the different ways that machines can actually learn from data. Okay, so let's just dive right in. Here's our roadmap for today. We're going to start with the basic blueprint. What even is machine learning? Then we'll look at the raw materials it's made from, we'll follow the assembly instructions, explore the different kinds of learning, and finally, we'll see what this amazing technology actually builds out there in the real world. First up, the blueprint. Before we can understand how to build something, we've got to know what it is we're trying to build in the first place. So what is machine learning at its core? So here's the crucial difference. Traditionally, you would write pages and pages of code with super specific step-by-step rules for a computer to follow. But with machine learning, you kind of flip that on its head. So instead of trying to write a million rules to identify a cat, you just show the computer thousands of cat pictures and it figures out the rules of what a cat looks like all by itself. And that right there is the fundamental promise. We are creating systems that can spot patterns, make predictions, and, this is the most important part, adapt and get better over time as they see more and more data, all without a human programmer having to go back in and constantly tweak the code. Okay, so now let's unpack the raw materials in our builder's kit. What are the absolute essential components that you need to get any machine learning system up and running? Every single ML system, no matter how complicated, is built on these four pillars. It all starts with data. That's the fuel for the whole process. From that data, we pull out features, which are just the key characteristics. Then we apply algorithms, and you can think of these as the recipes for learning. And finally, we go through training, which is just the process of using all that data to make our recipe as accurate as it can possibly be. And this is a great way to picture what data usually looks like in the real world. It's not some abstract magical thing. A lot of the time, it's something as simple and structured as a spreadsheet. The rows are your examples, let's say different houses for sale, and the columns are the features, things like square footage, number of bedrooms, and location. Now this slide really gets to the heart of what algorithms are all about. It's not just one magic recipe, it's more like a massive toolbox. Just like a carpenter has all sorts of different saws and hammers for different jobs, a data scientist has hundreds of different algorithms. The real skill is knowing which tool, which specific algorithm, is the right one for the job you're trying to do. Okay, let's move on to the instruction manual. We've got the parts, we've got the tools, so how does this all actually get assembled? What's the process a machine actually goes through to learn something? At a high level, it's this beautifully simple but incredibly powerful loop. First, the machine just observes the data we give it. Then, it infers patterns. It starts to find all these hidden relationships between the features and the outcomes. And finally, it uses those patterns it learned to predict what's going to happen with new data that it's never seen before. So our builder's kit, like any good kit, comes with a few different instruction manuals. Each one is for a different kind of project. These are what we call the major types or flavors of machine learning. The two most common types are supervised and unsupervised learning. With supervised learning, it's like you're giving the machine an answer key. You give it 1,000 emails already marked as spam or not spam, and it learns to make predictions based on those correct answers. Now with unsupervised learning, you give it a bunch of unlabeled data, and it has to find the structure all on its own, kind of like grouping your customers into natural segments without you ever telling it what to look for. And as you can see, this table really fills out the whole manual for us. Beyond those first two, you've got semi-supervised learning, which is a hybrid approach you use when labeling all your data is just way too expensive. But then there's reinforcement learning, and that's a totally different way of thinking. This is all about learning through trial and error. Imagine teaching an AI to play a video game. You don't give it a rule book, you just give it a score. It gets rewarded for good moves, penalized for bad ones, and after millions of tries, it eventually learns the best strategy to win. So after all this building and all this learning, what do the finished products actually look like? Where do we see machine learning in our day-to-day lives? Well, the answer is practically everywhere. Machine learning is the engine that powers the movie recommendations on your favorite streaming service. It's helping doctors diagnose diseases from medical scans much faster and more accurately. It protects your bank account by spotting fraudulent transactions. It's literally what makes your voice assistant understand what you're saying and what powers real-time text translation on your phone. But, And this is a really big but. Building these powerful tools comes with a huge amount of responsibility. A model is only ever as good as the data it's trained on. Real success isn't just a given, it depends on having high-quality, unbiased data, picking the right algorithm from that massive toolbox, and thinking very, very carefully about the ethics of how these systems are designed and used. And that last point really brings us to the most important takeaway. We've just unpacked the whole builder's kit for machine learning, but the real power of this technology isn't just in understanding the pieces, it's in how we choose to put them all together. Because building a great model takes skill, but building a beneficial one, well, that takes wisdom.